In week 6, we were tasked with implementing tune outlines with silhouette detection, so modifying the outline rendering to detect silhouettes dynamically. Instead of rendering back faces, implementing a technique that renders outlines only where the angle between the normal and the camera view direction exceeds a threshold. So this was the code that we were given, and it generates a sphere. It should generate a sphere. It generates a sphere with these triangular sections, and then of course the shadows are generated flatly, and so we took this and turned it into this. So as you can see, we have a smooth silhouette shadow and a nice thick line around the entire sphere. All right, so let's go through how this works. So the outline, Brian should talk about this, but I want to talk about the camera position. So the first thing is, in order to get this, I have this little diagram here. In order to get this line that goes around the entire thing, we have to find the camera position. So we set it at z equals 10. So this is like 10 increments from here. And what we're trying to do is find the point at which the ray from the camera is 90 degrees shoots off 90 degrees. So for example, if the ray is going straight down the middle right here, it's going to bounce back at an angle of 0 degrees, right? But if it hits at the edge right here where we want this line to be, it's going to shoot off at hopefully a 90-degree angle or somewhat close to it. And that's how we get our outline. So the camera position is necessary in order to do that, and then we have to pass that to our render outline function. So that is changed. Let's see, where's my shoot? Okay. And then I'm going to talk about the render model. So the first thing you notice is that it's smooth instead of, yeah, I'll just pull this up so you can see. First thing that you notice is that it's smooth. In order to achieve this, we have to change the way that the model is shaded. So the first thing is using this GL shade model, GL smooth, and that uses smooth shading, which interpolates colors between vertices. So all those lines on the triangle, those are the vertices, and it creates this gradient effect across the surface of the model. Because each vertex has its own normal, and the color is calculated per the vertex and interpolated across the face. So in the textbook version, we're using GL_flat for flat shading. So you have a single color for the entire face, and it creates this like blocky appearance. Okay, let's talk about this for loop here. So hang on. Well, we need to talk about the normal calculation because that's important too. So in the textbook version, they're calculating the entire face using the calculate face normal for the uniform color. So each, man, I should really pull the calculating these for these squares, or the triangles, excuse me. But in our version, yeah, see, so it's one solid color. Okay. Now in our version, each vertex has its own normal, and this creates a smooth transition between the faces. So in the textbook version, it almost kind of looks like it's not entirely round, but the smooth transitions help with it giving the appearance that it is. And then finally, this light intensity is also important because it's calculated per the vertex, whereas in the textbook we were given it just quantizes the cell to create this shading effect. So we have to get rid of the quantization, and so we're not rounding the light intensity, and that's why we have to use this for loop, is also why. And then which brings it to the vertex rendering loop. So it loops through each vertex of the face and sets the color, normal, and position individually. So it allows for per vertex lighting and smooth shading, whereas in the textbook it loops through each vertex, but it uses the same color, which is based on the face normal for all vertices. And the color is set once on the face. I'm talking about the textbook version. The color is set once, and the same color is applied to all vertices of the face, which is consistent with flat shading, whereas we need smooth shading. So we're using smooth shading, vertex normals. The light intensity is per vertex. The color application is per vertex, and we're using all this to create that smooth gradient effect. And I believe Brian will talk about some of this stuff, the hash map. All right, that is all.